Question number 13. Beams of electrons and protons move parallel to each other in the same direction. They attract each other, repel each other, neither attract nor repel. Force of attraction or repulsion depends upon speed of beams. These are the options. So here you can see that electrons are moving in one direction and protons are also moving in the same direction. Since electrons are moving in this direction, the current will be in the opposite direction. Conventional current for protons, the conventional current will be in the opposite direction as that of electrons. So here you can see that currents are anti-parallel. So anti-parallel current repel each other. So the right answer is option B. Question number 14. A ray of light of wavelength 600 nanometer propagates from air into a medium. If its wavelength the medium becomes 400 nanometer, the refractive index of the medium is. So here this is a direct question. We know the formula N21 is equal to lambda 1 by lambda 2. So over here lambda 1 is 600 nanometer and lambda 2 is 400 into 10 to the power minus 9. So this will get cancelled. 6 by 4, that is 3 by 2, 1.5. So the right answer is option B, 1.5. Question number 15. A long straight wire of radius A carries a steady current I. The current is uniformly distributed across its area of cross section. The ratio of magnitude of magnetic field V1 at A by 2 and V2 at a distance 2A is. So here you have a long straight wire. Let us say this is a straight wire which is having a radius of A and which is carrying a current of I. So you can see that the current is uniformly distributed across the area of cross section. Now in the question we need to find the magnetic field B1 at A by 2 and B2 at 2A. So if you calculate B1 at A by 2, you know that the current is only for A by 2 part we need to calculate. And we can apply the Ampere circuital law also. After that we can find the magnetic field. So how do we calculate the current for the area of cross section whose radius is A by 2? So let us say this is the area of cross section through which the current is passing. This radius will be A by 2. So total current is I for the entire area of cross section. So current per unit area will become I divided by pi A square. So this is the current per unit area of cross section. So now let us calculate the magnetic field at B1. So if you apply Ampere circuital law, we can find out B integral B dot dl will become mu 0 I1. So I am writing B1 dot dl will become mu 0 I1. I1 we need to find out. So if you apply this one, you can see that dot dl angle will become 0 if you consider an Amperial loop. So the angle for the magnetic field and the length element will become, angle between them will become 0. So integral B dot dl will become B1 into dl, that will become mu 0 I1 and dl will be, so this B1 since it is a constant we can take outside the integral, and integral dl will become 2 pi A by 2. A by 2 is the radius. Now we need to find out the current. Current is I1. So I1 is passing through the area of cross section which is having an area radius of A by 2. So you will be getting current through the area of cross section will be current per unit area, that is I divided by pi A square into the area of cross section, that will be pi into A by 2 whole square. That is current per unit area of cross section into the area of cross section. So once you simplify this, you will be getting V1 will become mu 0 I pi A square. In that you can say the pi A square and pi A square will get cancelled over here. You will be getting V1 is equal to mu 0 I divided by A by 2 whole square. So the 4 is here and the 2 pi A by 2, in that the 2 and this 2 will get cancelled. So you will be getting mu 0 I by pi into 4 into A will come. So 4 pi A will come. So this is the magnetic field, that is B1 is equal to mu 0 I divided by 4 pi A. This is the magnetic field due to the first part. So we are writing it as equation 1. Now for the second one, you can see that for the second one, the radius is, the distance is 2A. So 2a means it will be outside the conductor. So this is a conductor, so it will be somewhere over here. We can draw an Amperian loop. So if you apply that, the current is same only here, because current I will be passing through the area of flow section. So we can calculate B2 in the same format. We can find out B2 into, if you take the Amperian loop and integral dl, if you do it, you will be getting as 2 pi into 2a will come. Okay, that will be equal to mu 0 into I will come. So here B2 will become mu 0 I divided by 2 into 2, 4. So 4 pi A will come. So if you see these two values, B1 and B2 are same, right? So we can say equation 1 and equation 2 are same. So the right answer will be option B.